So if you were astute yesterday and you were reading the schedule, you would not have seen today's presentation on the bill. Normally what happens at these events is the agenda is worked out months ahead of time, and you get weeks and weeks to do this, and you create your presentation, and you're very relaxed, and you peer review it with colleagues. And then occasionally what happens is a speaker has to pull out. And if you're really unlucky, at 10 o'clock in the evening, after your presentation, you get a call that says, hey, someone's pulled out tomorrow. Would you mind doing a presentation extending on what you did yesterday, but a completely different topic? And you look a little bit more like this. If you're really, really unlucky, then they go on to say, oh, and by the way, I know that your product's not released yet. I know it's still in development, but would you mind doing a live demo on stage that you've never tried before? And then you look like this. So this is going to be a journey. I'm as keen to find out how this goes as you are. Bear with me. There will be a few bumps along the way. A little bit about us as a company, Datalytyx. So as an organization, we have 3 primary offerings. Oops. Well, that's doing it, sorry. How's that? Gallium, which is our smart IoT time series technology, time series compression technology, which you can see displayed in our stand. Essentially what that does is all about taking time series, sensor, IoT telemetry data, reducing the volume dramatically, typically of order 100 to 1, but keeping all of the business value. So it's we typically say you can get 99% of the business value from 1% of the data. This is very specifically for time series data, so use cases are connected cars, smart factories, connected aircraft, shipping, offshore energy. The second offering we have, which I'm going to focus much more on today, is Palladium, which is our data platform as a service. This would be used by organizations who are more into traditional big data. And then we have a whole set of managed service offerings which underpin both of those and some other third-party technologies we support as well. A little bit about the customers we work with. I'm not going to go through these. There's some household names up there. You can read those yourselves. Okay, what I'm going to talk about today is 2 problems in customer experience. The first one, and it seems a really obvious question, but actually isn't, is who is the customer? We can't talk about customer experience in any way, shape, or form unless we can identify who the customer actually is, and it's not that obvious in a lot of cases. The second problem I'm going to try and tackle is how do we keep up with the speed of customer requirements? And these aren't just requirements from our customers, they're also requirements from our business wanting to know about our customers. And across all of the different sectors we work in, we typically find that people driving information and value about customers have the fastest requirement cycle. They want to change their minds and get new things far more frequently than, say, for example, manufacturing or advertising. Those things have typically a much slower development cycle. So in customer analytics and customer experience, the pace of change of requirements about customers is far higher than any other place, and that creates a bunch of problems. So let's start with this: who is a customer? And I'm going to use a case study from one of our customers, who most of you will know, Hermes, the parcel delivery company. They're actually an incredibly interesting company and doing great work at becoming a truly data-driven business. For them, a customer is a parcel recipient, someone that receives a parcel. They're not the person that sent it. They may be the person paying the bill, but the actual customer is the person that, you or me, who's getting a parcel from Amazon or wherever. And they do hundreds of millions of these a year. So their starting problem is I have hundreds of millions of customers even in the UK. Now you say, well, hang on, that's not possible. There are less than 100 million people in the UK. How can you have hundreds of millions of customers? The answer is there's a lot of duplicates. But people don't go to the Hermes website and sign up and then get deliveries. So the creation of a customer entity is not a nice orchestrated sign-up process where they come to your website and they enter their email address and their mobile phone number. Customers are created almost as an accident by the fact that a retail company created a delivery request. So the customer creation is actually from a delivery company, an Amazon or an ASOS or whoever, that says, I want you to take this parcel to this person. One of their problems is the data rates at peak are huge. They're talking about thousands and thousands of new customers a second at peak times. And they have and we've developed with them a set of very, very complex matching rules to try and detect when this new customer that's appeared is actually a duplicate of an existing customer. And ultimately, their goal here is to create golden or master customer records. They can't do anything with customer experience until they can actually pin down who is my customer. Why do they want to do this? So they explain a really interesting story to us, and you probably can't see a lot of this at the back, so I'll talk through it. Sam Smith, living in a particular postcode, receives a parcel. And he orders online, and he says, my safe space if I'm not in is a shed. So that goes through the system, and at some point ends up in his shed. Hermes will link the information they have about that customer into their database, and will note that the customer preferences for that particular entity wanted it delivered in a shed. A month later, a new parcel by a Mr. S. Smith at a similar address is requested, and also says, my safe place is a shed. So the same thing goes to the system. They create a new record, because it's not Sam Smith, it's S. Smith, and the address doesn't quite match, because people don't always enter their addresses the same way. And the same process follows. But the system has now said, okay, these two are sufficiently similar. I think there's a very high chance that these two entities are the same. I'm going to create a master record for Mr. Sam Smith at this address. And what happens the third time a parcel is requested, or a parcel is sent to Mr. Smith at that address, the system is going to say, I know who Mr. Smith is. This one doesn't have a safe place specified, but that's okay. I can use the information I've gleaned about Mr. Smith from other deliveries. I've created this master record. I now know that his preferred safe place is his shed. I'm going to send him a message and say, Mr. Smith, we're delivering to you today. If you're not in, would you like us to leave it in your shed? Yes, he would. That's great. That goes to the driver. Delivery goes into the shed. The other side effect of this is now we've got a record that Mr. Smith has actually approved that. So when Mr. Smith makes a claim, we've got a record that this wasn't just something that come from a third party. We've now got a record that Mr. Smith has approved leaving it in that location. If it's gone missing, we as a delivery company are now not liable. So this personalized experience is the goal of many retailers, many people in delivery and logistics, but it really starts with a fundamental problem. If I don't know who my customer is, everything else is irrelevant. So we've seen they want to personalize the customer experience. Reduce fraudulent claims. If I know who my customer is, it's much easier to identify who is trying to pull a fast one and who isn't. And conversely, just as important for customer satisfaction, if Mr. Sam Smith has received 100 parcels this year and rings up and tells me one's gone missing, it's pretty unlikely he's chancing it. He is now a reliable, respected, trusted customer. We should fast-track his process for a refund very, very quickly because he's a valued customer, and we can say very quickly we think he's on the level. We can optimize delivery options. All of a sudden, we know that every time we deliver to Mr. Sam Smith on a Wednesday, he's always out. So we could deliver to a shed, or we could send him a message saying, it looks like you're often in on a Thursday. Would you like us to move your delivery by a day instead so you can receive it? As soon as we've got this master record, we can now do some quite clever things. And ultimately, this for a delivery company means building loyalty and delighting their customers. So that's just kind of one example, but there are many others of the starting point for customer experience has to be, I identify who my customers are. Now, if you're in a web business, you might say, well, this is straightforward. Customers sign up on my website. I was talking to a company recently that said, it's no problem. We have a database. Everyone signs up. I got their email addresses. And I said, so you're saying that you offer a 30-day free trial, yeah. So you're saying that no one has ever used a different email address to sign up for your 30-day free trial more than once? Oh, no, we know that happens a lot. Okay, so when you've got 1 million rows in your database, those are not 1 million customers. Those are maybe a third of 1 million customers, each of whom has signed up for your free trial 2 or 3 times. So even people that think they've got these master records, actually when you look at it, very often haven't. Okay, that's the first piece. The second piece is, which I want to focus on more, is how do we keep up with the speed of these requirements? How do we keep up with the speed of changes? I'm going to talk about our Palladium platform a little bit, and I'm going to use that as an example. Just to kind of baseline, our Palladium platform is a fully managed, fully cloud-based, end-to-end data platform. So there's no installation, there's no maintenance, you pay a monthly fee for it, everything's included. You just turn it on, managed 24/7. It's infinitely elastic, so it starts out at very, very low cost for small scale, for trials and small customers, but it scales to the very, very largest customers. You see, we're talking to people who are doing 300 million customers, and thousands of transactions a second. One of the unique parts of Palladium is expertise is included, so it's not just a service of the software. We include in each of the subscriptions an allowance of days for access to our own internal experts, so data engineers, data architects, data scientists. Because just giving someone a platform, particularly if they're relatively new to the data world, isn't enough. To deliver value to the business, at least starting out, they need some help. Maybe they've got the data engineering crack, but they need some data architecture help. Or maybe they've got all of the data integration piece, but they want to move into the data science area. So we include a set of expertise in that. We have some of the most advanced automated ingestion technologies for both cloud-based sources and on-premise sources. And in fact, yesterday we, at the other end of the building, we attempted an unofficial world record for ingesting 100 databases, I think 1,400 tables, 15,000 columns, and 100 million rows of data from a completely empty system to a fully working data warehouse, and we did it in 187 seconds. So we think we've got the ingestion piece cracked. And this is critical because in typical big data projects, the simple ingestion data engineering piece historically has been about 70% of the time. So if we can take 70% of a big data project and reduce it down to 3 minutes, that frees up a huge amount of time to do the interesting stuff. What is the interesting stuff? Well, actually, the interesting stuff is talking about the modeling. When we do ingestion, we're ingesting data in a very raw form. We're taking the data as close as possible to how it's represented in the source systems, our actual sales system, our actual ledger system, our actual HR system, and we're landing that in a very raw form in our data lake and our data warehouse. The only transformations we're making are things like governance. You may have to mask out credit card information, you may have to mask out certain PII, but broadly speaking, we're bringing it in as close as possible to the natural form. That's not what the business needs. The business needs it in a very curated, modified form, and this is what the modeling scope covers. Okay, so let's look at this modeling piece in a little bit more detail. When we ingest it, we ingest in the source domain. So everything that's coming on the left-hand side here, so everything in the first column here, is pretty much a one-form replica of the source systems. We're doing some ingestion, we're doing some curation, we're normalizing some values. Maybe they've come in different currencies and we're standardizing currencies. We're doing exchange rates and stuff like that. But everything is still a one-for-one replica of the source systems. The really important piece comes when we transform that from our ingestion and curation layers up to our calculation and consumption. This is where we turn source domain data into business domain data, or you'll sometimes hear them called marts. So for example, in the bottom two here, we've taken data from our sales system and data from our marketing system, we've merged that together, and we've created a business mart for customer experience, pulling together multiple sources of data. And then from these business marts, from these business domains, this is where the business consumes it, whether that's visualization, BI analytical tools, whether it's data science, or more recently, people are getting into data sharing. My data, I've pulled a lot of my data to a valuable point, I now want to share it with other people. You think about the Hermes use case, they have got master records of almost everybody in the country and confirmed details of names, addresses, telephone numbers. They put a lot of work into building up that master database. Maybe that master database is worth something to other people who also want to validate, well, is Mr. Smith and Mr. S. Smith and Mr. Sam Smith roughly this address the same person? So a lot of focus on data sharing and monetization happening. One of the really important parts of modeling is modeling for maintainability. And what we see far more often than we would like is you go into organizations and they say, yeah, we do this. We pull all the source data together, we do some aggregation, we join it all together, and it looks like this. And when the first person developed this, it never started out like this. It started out as 3 lines, and then 4 lines, and then 5, and then 6, and then 10. Then someone else picked it up, and it turned into 20, 30, 40. And now it's this absolute monster. And one monster is fine. What happens is, and we'll see in a minute, someone says, I want to do something different. Right, I'm now going to copy the monster, and I'm going to change 2 lines of it to create a new monster, and a third monster, and a fourth monster. And what started out with the best intentions turns into an absolutely unmaintainable system. We treat modeling and data modeling the same way we treat software development and code. Rather than creating one big monolith, we say break everything down into the smallest possible meaningful blocks, and we end up with lots of blocks, but everyone is simple, everyone is easy to understand, everyone is maintainable, and then we start assembling building blocks together. So in the software world, we take functions, we assemble them into libraries, we assemble them into small pieces of code, maybe we call these microservices, and then we assemble lots of microservices together to make a complex system. So the basic design pattern here has been accepted in the software industry for the last 10 years. We're taking that to the data world. And we'll see why this is important in a minute. So we achieve the same thing by saying, okay, we'll have 2 or 3 or 4 small blocks, each one doing one job, and then we'll cascade them together. What that means is, when I've got a new requirement, I want to do something a little bit different. I don't have to reproduce everything. I can say, right, I can inherit up to that point, and I just need a new way of consuming that data, a slight variant on it. And we'll see a practical example of this in a minute. So this is, I'm just a quick time check. Okay. So this is what it might look like in practice. Each of these circles on the ovals on the right-hand side is a model. So we have, at the bottom, we have models representing our individual source tables. We do some basic curation on that. Then we start joining and mixing these together up to the calculation layer and the consumption layer. The line through the middle here, remember, is where we change from the source domain to the business domain. That's the most critical piece here. The transition from data that looks like the sources it came from, transformed into data looking the way the business needs. That's the most critical piece of this modeling and transformation process. Okay, so now I'm going to try and demonstrate this live in a real use case. To set a bit of a baseline, what do I have? First of all, what I have is my browser closed, which is not a good start. So bear with me. So our example scenario here is a company that's got it's already got a pre-existing data warehouse built from some sales and some marketing information. They've pulled that together into kind of a sales orders system. And we're going to look at that on a baseline, and then we're going to go through the process of what happens when the business requests a change. Remember, the problem we're trying to solve here is the business is going to be requesting changes very rapidly. So what we want to do is take a process that would typically take days or weeks and try and reduce it down to hours or even minutes. Unfortunately, the Wi-Fi here is also kind of slow. Okay, so let's have a look at... So right now I have this sales orders database, which you probably can't read. Unfortunately, let me see if I can zoom in a little bit. On the left-hand side, I have the sales order database, and I have those layers we saw. I have our ingestion layer, our curation layer, our calculation and consumption layer. And if we just focus on the consumption, we see we've got a few different ways of consuming this data already. So we're not starting from fresh. Yesterday, I started out with an empty system and built a complete data warehouse from scratch. Now we're saying we've got a data warehouse in place, and someone's asked me to make a change to it. If we visualize that through a documentation system, this is kind of what it looks like. And it's that same diagram I showed previously, just rotated 90 degrees. So on the left-hand side, we've got all of our sources. This is where we're ingesting from. And you can now see graphically how these models inherit from each other, and you can see where all of the joins and the merges and the transforms are happening. Now, there's an interesting looking model on the right-hand side here called fact sales order, which we're going to come back to in a minute. But this is our baseline. This is the system we have. Let's look at our scenario. My boss, a business stakeholder, comes in and says, I need the lifetime value in the minutes since last order per customer. And I need it in production because we're losing money every day from not having it, and therefore I need it by tomorrow. And anyone that's working in this space will recognize this as the totally unrealistic request that people get every week. So where do we start? Well, we saw that we had this sales order table that looks like it may have the information we need in it. So let's go and have a look. Let's go and view the documentation for this. So we know we want it by customer ID, and we've got that. Let me zoom in a bit here. We know we want the total order value, and we've got that. And we know we got the order date. So we've probably got the right information in this model to answer the question. If we just go back to the overview, remember that big SQL on the left-hand side, what we're trying to do is achieve this new business requirement with the fewest, smallest, simplest changes possible. So I don't want to recreate all of this stuff over here. I've got a consumption model that already has the data in it I need and is already inheriting from a whole bunch of clever work on the left-hand side here. I just want to reproduce that model and make a few changes to it. Inherit from everything on the left-hand side. So I'm going to try and do this live. And I apologize if this is not visible at the back. So, the first thing I've done is create a branch. For those of you that are not familiar with Git, basically creating a branch is a way of creating a little sandbox. I've just said I'm taking the main code base that built all of this, because all of this is built from code. Like I did in the demo yesterday, I built an entire data warehouse just from code. I've taken that code, I've created a copy of it, or a branch of it. There's a little sandbox for me, then this is where I'm going to do my work. Now that in software development is pretty straightforward. The additional piece we need to do here is, this is a data world, so just having the code is no good. I need to be able to see the effect of that code in a real data warehouse. So what I'm going to do here is deploy my code, but rather than deploy it to production, I'm going to deploy it to an empty database. So I have, if I look in here, an empty database called dev customer experience. And you can see there's no schemas, no tables in it. So I'm going to deploy that, and I'm going to update my documentation. And what this is doing is a baseline. I'm now creating my own complete standalone sandbox that's a perfect replica of production. Because if I want to make some changes, first of all, I need to know what I'm making changes to, and I need to be able to see the impacts of those. So I'm building a complete replica of the production data warehouse in my own little sandbox that no one else can see, no one else can touch. And more importantly, when I mess this up, which I will because I'm human, and I definitely will because I'm on stage, I can't impact production. I'm in my own little safe sandbox. So we'll go and refresh the documentation. Documentation shouldn't change, because all I've done is say, take that thing in production and create a copy of it in my own little sandbox. So this should look exactly the same. Then what I'm going to do is say, well, I know that this fact sales order model has got the information I need in it. So I'm going to create a copy of that, and I'm going to try and make my changes to it. So I will copy this bit, and then I'm going to bravely make the changes by hand. OK, so I've duplicated my sales order model, and I've called it the customer experience status model. And if we edit that, we can see, well, you maybe can't see that. I apologize, the red on black doesn't work very well on the screen. It's got all the information I need in, but it's got a bunch of stuff I don't need. So the first thing I need to do is say what I want this to be called. So I'm going to change this to customer experience status. I don't need the sales order number. I do need the order date, because I need to know how long they ordered. I need the total. I need the customer ID, so I can get rid of everything else. I'm going to put the customer ID at the top. And because I want a result per customer, I'm going to put a group by one. So I'm going to group by customer. So what's going to come out of here is a record per customer. And if I remember, we wanted the total value. So I'm going to call this total lifetime value. And then I wanted the number of minutes since they last ordered. So I need to do a difference of the date diff in minutes, between the current date and the maximum, i.e. the most recent order date. And I'm going to call that minutes since last order. Now I could choose to redeploy this entire thing, but that took a few seconds, and if this is massive, that might have taken a few minutes. So what I'm going to do is deploy just the new model, because I know only one thing's changed. So I'm just going to say deploy the model called customer experience status. And with a bit of luck and a following wind, so what it's doing, first of all, it's compiling that to make sure that it's valid, that all of the integrity works. Now it's deploying it to my data warehouse. So we can actually go and see that in practice now. Remember, I'm still in my sandbox. I haven't impacted anybody. If I made a mistake, which was very likely, I haven't done anything to impact anybody else. But I can now see, in addition to the other stuff, I've got this new, well, OK, it's ignoring the typos. I've got this new table. And if I look at it, I've now got customer ID, minutes since last order, and lifetime value. Now, I could at this point deploy it into production. But this is not my first rodeo. I've been here before, and I know what customers are like. I know what stakeholders are like. How often has this turned into this? Oh, yeah. I know that's what I asked for, but it's not really what I want. This is a fact about customers and stakeholders, is they don't know what they want until they see it. Rather than deploying to production, since I now have a perfect replica of my production database with my changes, I can sit down with the stakeholder and say, is this what you asked for? Oh, well, no, I also need the average order size and the number of items. OK, well, that's fine. We've seen how quickly it was to change it from scratch. I can add a couple of rows to this. And in fact, this is so quick, rather than having to schedule meetings with stakeholders, it now becomes legitimate and feasible to sit your stakeholder down next to you and do this iteratively. You want to do that. You want to do this. You want to change it. And every time I make a change, I can redeploy the entire thing to a perfect replica of the production environment. They can see exactly how it looks. They can change their mind. You know, we're agile. We shouldn't be afraid of change. We should be embracing stakeholders changing their minds, because ultimately they're changing minds for good reason. It's going to be better for the business. We shouldn't fight it. We should embrace it. This means I can sit down with a stakeholder, and in 20 minutes I can do 30 or 40 iterations of what they want. Once I get them to the point where they're happy, then what do? I'm not going to go through this workflow. So first of all, I would create some automated tests. We treat our data warehouse modeling and transformations the same way we treat source code, which means when we commit a change, we also commit a test for that change. So creating automated tests is as simple as the creation of the code. I haven't done it, but we would create some automated tests. We'd commit that alongside our code change. I'd then commit that change, and then I create a pull request. People are human. People make mistakes. The best people make mistakes. Every smart developer I know will refuse to check in code unless one of their colleagues has checked it. They could be the most experienced developer in the world. They know that they will make a mistake one day, and they want one of their colleagues to peer review it. So I create a pull request, and one of my colleagues checks my code. If they're happy with it, they approve it. If they think there's something that could be improved, they let me know, and I make those changes. Once they've approved my full request, it's merged back into the develop branch. So I'm now off my little sandbox. I'm now into the main develop branch. This will be promoted to QA and a set of automated tests. And remember I said we check in our tests with our code. So we don't just deploy stuff to production hoping it's going to work. We deploy stuff to production knowing through a set of automated tests that when I deploy it, it will work. That's one of the critical things about treating everything as code and following a software development lifecycle for data is when I push to production, I know it will work. I don't hope it will work. If it passes, we promote to master. That promotion can be manual or it can be automatic. And then finally, we deploy master into production. And you've seen how quickly it is to deploy. I just do my Palladium deploy, and it pushes everything from the repository into the data warehouse. I could do that now. If I drop to the target dev customer experience, I could push this into production now. I wouldn't, because I'm not following the right life cycle. But the action to actually push it into production is no different to pushing it into my sandbox. And this is a true case. We normally have to compromise. We normally have to say, I either want to do it faster or I want to do it safer. But speed is the enemy of safety. Speed is the enemy of trust. If you follow a proper software development lifecycle for data, you genuinely get the holy grail of it is faster, but it is also better, more robust, more secure at the same time. You get both of these. You don't have to compromise. OK, so a final review. What are the benefits of this? Improved governance and change control. Every single change that arrives in my production environment has started out by someone making a change, and every change they made, every person that peer reviewed it, every time it was promoted, every automated test run, everything is documented, what happened, where, and when. Maintainability. We saw we're not dealing with these huge monolithic blocks of code anymore. We're dealing with these small, atomic, easy to maintain objects. I could never have modified that big lump of SQL we saw on the left-hand side on stage and stand any chance of doing it. But a simple model with 5 or 10 lines, I stand a reasonable chance of getting that right first time out. Testability. You've seen the testability live. I made some changes and I deployed it into my own sandbox to prove it worked. So I can test it myself, but I also have the ability to run automated tests all the way up the stack. Availability. Because of all this stuff, when it gets into production, it is much, much, much more likely to work. But there are always the 1 in 1,000 or 1 in 10,000 edge cases. Because I've deployed this, because my code repository is now the center of my world, and essentially my data warehouse is just a transient implementation of that, if I deploy it to production and something goes wrong, I don't waste hours messing about with what went wrong, why did it go wrong, how do I fix it in line. The step is straightforward, and it's been the same as it's been for software 10 years ago. I deployed it, it broke, I roll back to the previous version, and I redeploy it. That's it. No messing about, no arguing, no debating. If I see something wrong, I roll back to the previous version and redeploy it, and I should be back onto the previous version live in production within 60 seconds. So it's much more highly available at the outset, but it's also, in the very rare case where something goes wrong, it's dramatically easier to get back to a known good state. And then finally, which hopefully is a big takeaway from this, speed of development. I was able to take, okay, a relatively simple new business requirement and make a real change and deploy it and test it live on stage in 4 or 5 minutes. If I can do that here, how quickly could you do it in an office without being on stage, without bad Wi-Fi? Realistically, we're expecting developers in this environment to be able to do 20 or 30 real iterations in an hour. And that's probably compared to the 2 or 3 iterations they can do today in a full day. So with that, I thank you very much. Have we take any questions?